tutorial from W3 schools. Idea is just to revise list a bit before we start doing questions on lists. So we'll just quickly understand how lists work. Then I'll introduce some. How many of you remember lists in Python? Some of you. Not too many of you. Okay, so we'll pretend that we don't know lists, kind of, and we will start with working with lists, and then we will move on. Okay, I think I'll go down. You'll be here. When I use the board, I'll do that. Yeah. So we will start with. You can also open W3 schools if you want, and those of you who have difficulty seeing the screen, we'll just play with it a little bit, not too much, just quickly run through so that all of us are on the same page. Okay. Now, normally I would start with an introduction of what is Python, why is Python becoming so important, and all of that. But I think I have kind of done that before, so I will not do it again. But I would just want to refresh a few things. Well, first of all, why are we doing Python? For the kick of it, or for the, because we have nothing better to do with our time, so we might as well learn Python. That's one way of doing it. But no, well, having said that, there is a certain sect of people, a certain group of people who program for fun. I mean, it's just program not because they are looking for a job and all that, but just program for fun. I also like that constituency because they are really, fans of programming. And then those people have various thoughts into how do I do this in this language. They also have a habit of picking up a lot of languages. They know Python, they know C, they know Java, they know C++, they know C#, they know JavaScript, and they know Go, and then they know Haskell, and the small talk, and there is a whole lot of language. And then some of the time it is very amusing and interesting to listen to them when they keep comparing different aspects of different languages. We call them connoisseurs of languages, connoisseurs of construct. And sometimes there are a lot of those people on YouTube also. If you feel like you should do, especially we call them polylingual people. Polylingual in the sense multilingual, multiplied many times. Well, I will not claim to be any of that, but I have had my share of languages, and I have had, when I was your age perhaps, the first language which used to be taught to us was Fortran. I don't know whether anybody in the world today programs in Fortran. It used to be called Formula Translation Language, whose sole purpose was to translate mathematical formula. We used to do, there was no computer science BTech when I was a student. It was only offered in MTech and that too in IITs. It was not offered in BTech. And in those days, Fortran used to be a language which engineers must learn. Why they should learn? Because engineers deal with a whole bunch of equations. They have these whole equations where they have to take derivatives and Simpson's rule and integrals and all that. They have to solve equations related to differential equations, partial differential equations, and matrix kind of problems, and linear algebra, and they have to take a whole bunch of eigenvectors and matrices and inverse of matrices, all these kind of stuff. And for that, Fortran was the best language. And we were told that Fortran, you should learn Fortran, and then you are an engineer. And if you are an MBA, Master of Business Administration, or a business kind of programmer, you should learn COBOL, Common Business Oriented Language. Languages have evolved. The only point I am trying to say is, today we are sitting at a point where Python has become a de facto language for all people dealing with any of these AI-derived subjects, which is AI, machine language, artificial intelligence, or for that matter, data science-based analytical applications. A whole lot of those applications are today choosing AI choosing Python as their de facto language. And part of the reason why they choose Python is that Python has a whole extensive set of libraries. It's a very convenient first language to learn. It is very simple. And it does not complicate your life by introducing too much of rigor of the syntax. C++, for example, is extremely syntax oriented. You need to do it that way. There's not too much of freedom. And if you have to pull, let's say, the third element to eighth element in a list, you need to struggle quite a bit, unless it's an array. You have to start with 3, go up to 8, follow the next pointers, and that puts kind of unnecessary pressure. What do I have? What do I want at the end of the day? Just want a slice of a list so that I can do something with it, add something to it, or multiply it with something. Or if you look at AI, I have to take a derivative, or I have to solve a simple matrix. In matrix, I have to add one row to another row. Now just imagine I have to add one row to another row. And try doing that in C++ or C, you need to write a very complicated loop, and then you have to write a logic for an I and a j, and then you need to do quite a bit of stuff, and then you're not even sure whether you got it right? So that kind of operations are very easy in Python to implement, especially what we call the slicing and the dicing. There is selecting parts of it and doing operations. The other thing is that there are these whole operations which will soon introduce called map, filter and reduce. What is map? You are given a list. This is something you do very common. What does map do? Take a list or take any collection of some kind, and what do? You work with every element of the array and transform each element of the array to something else. Maybe you want to square it up, or you want to add 4 to every element of the array. So in order to do that, that is called a mapping. That means you're not touching the array too much, you're just altering each element of the array. You're not playing with the size of the array. Size of the array remains as it is, and you're just doing some manipulation on each element of the array. Now there is a simple function called map which uses. Now if you have to do that in regular C++, what do you have to do? Now map has been added in C++ by the way, and in Java also, but that came from a Python inspiration. So what does map do? Just write a simple map and describe what you want your new element to look like, and it automatically happens. Same thing, there is something called a filter. Now, what is a filter? I want certain elements in the list, or I don't want certain elements. I should be able to say that very categorically in one line. I want all the elements which are greater than 0, or all elements which are greater than 0 and which are multiples of 2. I should be able to say it very easily. I shouldn't be forced to write a loop within a loop and made to check if condition and all of that, and then put it in another array and say that this is my output. So I have to build another array, filter out the elements. That is called filtering. Then there is a third operation which we call reduction. Reduction is what? Somehow you have to do, for example, you want to count the number of elements in an array, or you want to count the number of elements which qualify a particular condition. You are interested in the sum of the elements which fulfill a certain condition, or you are interested in the max of elements which are fulfilling a certain condition, or a min. So if you want to do all of that, it becomes pretty messy doing it in other languages, whereas you will see in a list it is pretty trivial, and you can do it in no time. So having said that, Python has made life easier for most of the programmers, and for a large community of programmers, especially people who do a lot of differentiation, integration, people who do a lot of matrix operation, which today is one of the biggest community of programmers. If you ask, what does a programmer normally do when he's writing an AI program? He would be doing derivatives quite a bit, because the whole of AI is based on derivatives, because you need to somehow compute an error and take the derivative of that error, and then somehow what is called backpropagate. We'll soon talk about all this. Backpropagate that error. So you need a lot of matrix multiplication and a lot of derivatives. Now you can do that in C++, you can do that in Java, you can do that in anything else, but Python lends itself beautifully to doing that. The other aspect, however, is that Python is remarkably slow. But in an AI world, you really don't care about speed. Okay, if you visualize the AI world, where does Python get used and why does C++ get used? Perhaps it's relevant because we are dealing with both. See, when in any AI system, and I'll have a lot of elaborate discussions on this soon. What do? You train your machine, you train your system. AI is all about showing 1 million pictures so that your program starts recognizing a cat different from a dog, different from an animal, different from a human, different from a car. That is what you are training your system. Now, training is not necessarily a fast process. It can be slow. And it is necessarily slow because you are going to train the system with 1 million images, million different kinds of images. So, a cat which is jumping is different from a cat which is sitting, which is different from a cat which is under a dog. Correct? So, all of them are cats, but they are in different contexts, and your system has to be trained to recognize that this is a cat, no matter what the context is. The context can vary. Context meaning whether the cat is standing or sitting or whatever. So the ability to recognize builds over time, and that is a relatively slow process. I really don't care because I am training it. Whereas in training is almost always done in Python. Because it's easier to train a system using Python. But now let's say you have trained a program to recognize an enemy target. You have trained all kinds of enemy target. Enemy target could include an enemy ship, it could include an enemy truck, it could include an enemy camp, an enemy tent, or an enemy contingent which is moving. You have trained your system to do that. Now you have developed the software. Now this software is sitting in a missile. So the missile is a guided missile, trained missile, and the missile is released. Now, the missile's training may have taken a lot of time. Maybe you have used Python and defined the parameters. But once it is trained and once it is aloft, once it is in the air, it has to do recognition, which is what we call inference. That it has to do in record time. It can't run Python there. You appreciate my point? While training, which is done in your lab, it can train on 1 million images, take its own sweet time, maybe over days. But once it is trained to recognize something, and that something comes in front of it, the recognition has to happen in record time, in a split second, nanosecond time. For that, can you use Python? You cannot. For that, you have to use C++. There is no other option. You cannot use Python then. So Python is a beautiful language when you have the luxury of time and the luxury of ability to spend more time. By all means, Python is a right. But when it comes to inference, when you have to attack, when the missile has to go after the target, it cannot waste time. It has to take that decision in nanosecond time or a very split second time. There we invariably use C++. We can't even use Java. Java is again too slow. Python is very slow, but Java is also very slow. And you have to write inferencing in C++. And that's why I was saying in the morning that, don't belong. A lot of people conclude AI world is Python world. Bunch of bullshit. It's not. AI's training world is a Python world. AI's inference world is a C++ world. And what do you do then? You need to develop programs which run in C++ on a GPU. Because all our missiles today are going to be equipped with a GPU. And the GPU has to work on split second time. And GPU, while you can program in Python, but that's like what I call a bullock cart on a highway. Right? You know what is a bullock cart on a highway syndrome? You have a highway which can travel at huge speed and you run a bullock cart on it. Can anything be worse than that? If you have a highway, you need to drive a Mercedes on it. Because otherwise you're not exploiting the speed. So if you have a GPU, you need to write a program in C++ so that you can exploit the power of the GPU. Python can't do that. Python can run, but Python can't exploit. You need C++ for that. So this polylingual or multilingual kind of concept is very important for all of us to endorse and embrace. Because the day I decide, why I'm saying this is because I've seen this happening. I'm a C++ guy. Who the hell made you a C++ guy? Did you get born as a C++ guy? When you were given your name, did they say C++ mantra? Did the pujari do that? No. You yourself, like an idiot, said, I am a C++ guy. If you are C++, if you are writing an inference program, while you are training, you are a Python guy. When you are writing a web application, you are a JavaScript guy. And when you are writing an application for any business program, you are a Java guy. So you are like a chameleon who changes their color depending on who is your customer at that particular moment. And we believe that engineers should become chameleons. They should not become identified with a particular language or a particular kind of application. I will dance to every tune. You change the tune, I'll change my dance. This is what is the mindset which I always hope that young people should have. Because don't ever have a mindset that I will do only full stack programming. I will do only AI. I don't know where some people borrow this whole perception. Okay? So please stay away from it. And that's why we are trying to, all the time, like we are having this class with you, I have a class with your seniors where we teach JavaScript, full stack program. So basically, and somewhere else we teach Android with Kotlin, okay? Or Apple program with Swift. So please grasp why I am saying this again. Please grasp the essence of the language. Grasp that silent nuance of that language. Don't get too worried about actual syntax. Syntax you can always get from the net. If you goof up a little bit, we live on the net, so you can do that. Don't worry about the syntax. It's idiots who worry about syntax. Grasp the essence. For this kind of problem, I'm using this language. For this kind of problem, I'm using this. It's a small point. I have to say it, so we are doing it. So here we start with a list, which is pretty trivial to create. If you see here, there are two to three things which I will notice. I am creating a list, my list, right now of strings, which are 3 strings. Now, there is something implicitly which is happening. Now, if I ask you, what is this? My list is what? What will you say? You will say it's a list. Will you say it's a list of strings? No, not necessarily. Because a list in Python can have strings, can also have a number in it. So I can edit it and add 1 to it if you want. So I think there is a way to add it in W3 schools. So I do that. Yeah, I just want to show you. So I just add comma 5 and I run it. Oh, it's really slow. So that is it. That is a valid list. So list is not partial to a particular element. So in Python we have list. We don't necessarily have a list of strings. So we have a list. So and how do I print that list? We just say print this list. That's one part. So nowhere have I said that what is its data type. It is just a list. It's just a data structure. Not saying it's a list of int or list of string or an array of string or an array of, it can be an animal, it may be a caterpillar, it may be anything on that list. Okay, next. Then there are certain important points about a list. List is ordered. List is changeable. Ordered means an ordered data structure is one in which you have indexing. That is, you can ask a list, give me your 0th element, give me your 2nd element, give me your 1st element, give me your last element. So any data structure which obeys that is called an ordered data structure. Like, for example, list is an ordered data structure. There will be a cousin of list called a set. The set will be an unordered data structure. Means what? You can't ask a set, give me your 1st element. He'll say, I don't have a 1st element. I have a bunch of elements, take them or leave them. I cannot say, give me 1st, give me 2nd, give me 3rd. That doesn't apply to a set. To a list, I can always say 1st, 2nd, 3rd, 0th, whatever. And then it is changeable. A list is mutable. We call it mutable. Changeable is old word. Mutable means that which can change. So you can change the list. You can change the values in an element, or you can add more elements, or you can remove elements. So you can change the structure of the list. You can also change the element values which are sitting in the list. For example, okay, we'll go forward. I think we have, okay, we can do that. There it is. Yeah, we can say after that print, next line, after the print, we can just say this list 0 is equal to something else. Okay. So we run that, and you know what you'll get. Well, you can also keep doing. So I change the list. This is mutable, correct? So you can also open W3 Schools and do whatever I'm doing. And please do, because that's how you'll get familiar. So this list 0 is equal to k minus. I did nothing. I just changed the first element, 0th element, to something else. This is changeable, correct? Or I can also say this list 0 is equal to this list 0, this list 0 plus kmi, string kmi. Let's see what happens when I do this. Okay, as you can see, I have not replaced that element. I have appended to that element apple kmi, because I said this list 0 is equal to this list 0 plus kmi. That is, go to this list 0, extract it, you get an apple. Apple plus kmi is apple kmi. Done? Are you all guys able to do? Oh yes. You can play whatever you want. Okay, as long as you continue to play, as long as you are in sync with what we are doing. Okay, next. So we have ordered, we are changeable. That is, we are ordered, we are mutable, and list is also allowing duplicate. Set doesn't allow duplicate. That is, you can have two apples in the same list and both won't get fused. There will be apple and another apple, no problem. So you can go on adding elements to a list. For example, you can go there and you see there are already two apples in the list. You can say this list, niche, after print list. You say this list, this list. How do I add? We'll see anyway formally. Dot append. You can say dot append. So you see, we are following the object orientation. This list is an object, and to it we are calling a predefined behavior. We didn't write this behavior, it came with the list. Dot append, just like you said in the morning, dot display. But there we wrote the behavior on student, because student was our creation. List is Python's creation, but it still follows certain object-oriented paradigm. So we'll say this list dot append kmit. So I'm adding another element to that list, and we run it, and we will see what we see. Yeah, so you see there, we have added an additional element, kmit. How do I add? Just say append. This list dot append, or whatever list dot append, whatever you want. And it need not be a string, as we just talked about. It could be a number, or it could be a letter, or it could be anything. Okay? So let's move on. So is everybody with me on this? That it is mutable, it is ordered, it is mutable, means changeable, and it allows duplicates. It tolerates duplicates, right? It doesn't get rid of duplicates. If I have a set and I add another element of the same thing, two things may happen. It will reject that element and give me an error, right? So that doesn't happen with a list. It's important to note. Okay. And then there are some very nice, useful things, useful functions, which are already built on a list. Now, functions can be called in two ways. We can say some of the things are called this list dot, like we just said, this list dot append. We did that. That is one way of invoking functionality on a list. The other way of invoking, or some other functions, they don't work that way. You say length of this list. Okay. You don't say dot len. You say len and pass list as a parameter. So these are general purpose functions. These are not functions specific to list. Len is general. You can say len on a list, you can say len on a dictionary, you can say len on a tuple, you can say len on a set, or something else. So they are generic functions, they are not specific to a list. Specific to a list, you will say dot. General purpose, if you want to use it, you say length and then pass that data structure, or pass that object. So see the way we did it. You said print length of this list, which will give you the length of that list, which will be 3. Okay, whatever, the answer is not important. You will get, is everybody clear? No, yes, we move on? Okay, we move on. So now we come to the issue of data types. So we are seeing three different lists here with each having one type of data. As we just learned, it is not mandatory. A list can have mixed data types also. That is, you can combine strings with booleans, strings with integers, no question, no problem. But here they are homogeneous lists. So you see that the first list is a list of strings, the second list is a list of integers, and the third list is a list of boolean. Just as a case in point, booleans, please don't forget to say uppercase T and uppercase F. Are you with me? Just keep that in mind as a general habit. Okay. So now here is a mixed list, a heterogeneous list as we call it. One member is a string, the next member is an integer, third member is a boolean, fourth is an integer, and fifth is a string. Perfectly fine. List never said that you should have only homogeneous list. I hope you understand when I say homogeneous and heterogeneous. Homogeneous means it should all consist of same kind of element. Not needed at all. You could mix and match the way you want. However, having said this, it's not good habit as a program. The language allows you to do that, as you are seeing. But please don't do this too much. It's not a good thing. Because often you'll get confused. What is this list supposed to represent? Is it supposed to represent students? Or students' ages? Or employees? Or department? What is it actually supposed to do? So if you mix, it's kind of confusing. As a programming habit, I would suggest, please don't use heterogeneous list. Language allows you to do that. But don't do that. You will come to grief at some point. Next. So, next we say, if you ask a list what kind of animal you are by saying type. Type is again like length, a general function, because it works on everything. So, if you want to ask a list what kind of animal you are, you will say I am a list. Okay? And how do I ask that? I just say type my list and it will return I am a list. So it will say class list. What kind of an animal I am? I am a list kind of animal. Okay. Anyway. Type will make a lot of thing when we are actually talking about matrices and all that. Type and shape matters because you cannot combine two matrices when the dimensions vary. So we'll look at the shapes of the both matrices. We look at the type of data structures they are, and we'll worry about it then. Either we don't have to bother. Okay. Now, So, here is something which probably we should talk about at a later date. But if you see, it's important you understand. Now, this is a constructor of a list by saying list. Similar to the way we said student, right? We said a student. If you just remember a few minutes back, we said student S is equal to student S, and in bracket we put the parameters for that constructor, right? And they were like parentheses. Now here we're doing something similar. You see, but apple, banana, and cherry. There are two parentheses. Just that apple, cherry, and banana, that parenthesis is called a tuple. So here what are we doing? We are taking one tuple. The tuple consists of 3 parts, but it's a tuple. We are taking a tuple as a parameter and converting it into a list. So we are taking tuple and building a list out of it. Is everybody with me? This is when you are converting a set into a list, a tuple into a list, or later a dictionary into list into a dictionary, dictionary into a list. When we do that, we use the constructor. Not very common use, but worth keeping in mind that you have something which you are not sure it's a list. Okay. So before I move forward, I think I should clarify. Very often in Python or in any of these advanced languages, you will hear this word, iterable. What is an iterable? Something on which you can iterate, means something on which you can loop. So a list is an iterable. I-T-E-R-A-B-L-E. List is an iterable. Set is an iterable. Dictionary is an iterable. Tuple is an iterable. So these are all iterables on which you can loop. Or you can say an iterable is a collection of elements. Any collection of elements on which you can loop. Loop means what? Go from the first to the second to the third. That is called looping. So any collection on which you can loop is called an iterable. So here I would say it in a more profound way as take a iterable and convert it into a list. In this specific example, that iterable happens to be a tuple. So I am taking a tuple and converting it into a list. So I can take any iterable and convert it into a list. Are you with me? How do I do it? List, constructor with list, pass that iterable as a parameter. So this tuple I am passing right now as a parameter. Next. So Python collections, yeah, right there. So there are essentially 4 types of collections that we will have to master. We are on the first one and we'll stay with the first one for some time. The 4 types of collections are list, which we know, tuple, which is also a collection of elements with certain restrictions. We'll talk about them when we arrive at the tuple. Okay, I don't mind saying a few things about a tuple. Why was the tuple created? Okay. I hope some of you have done C. All of you have done C, right? Yes? Or you have convinced yourself that you have done C? Fair enough. So, or JNTU has said that you have done C. The 3 different things. Knowing C, passing C, and actually programming in C. So, I don't know which species you belong to, but whatever. I am sure you have seen functions in C. No? Yes? Now, focus a little bit on what is a function's return type. You know what is return, right? What can a function return? Function can return a void, integer, a pointer, or if I ask a function to return 4 values, suppose I pass as an array. Suppose I want to pass an array as a parameter to a function and I say, from this function I want the min in the array, the max in the array, the sum of the array and the average of the array. What will you do? You understood my question? I want you to write a function, yes, which, only one function, not 4 functions, just one function, which takes an array as a parameter, maybe the size of the array as another parameter, and gives me back what? The sum of elements in the array, the min, the max, and the average. How will you do it? Sorry? No, I want it to return, not print. I want it to come back to me. Store them in another. So you would have to do one of 2 things. You would have to return an array, agree? In which first value, as our young friend says, should be first value is min, second value is max, third value is average, fourth value is sum, something like that. Or you can return a structure. Yes, no? You could return a structure in which you have 4 fields, min, max, average, sum. Correct? You could return a pointer to that structure, build the structure in the function and return all of that in one structure. But won't you agree that both these are very unwieldy, very ugly? No? I would like a more sweet thing like this. I call this function and I want min, max, average, sum as 4 variables. Are you getting me? No. So, can you write? Okay, let me write. Now this is important to understand why we need tuples. Okay, I'll just show you. What you do, so let's say there is a function, let's call it myFunc. And it takes an int ARR as a parameter and perhaps another parameter called length of the array. Okay? And you do all kinds of stuff. Okay? And then the question is, what should this return value of that function be? Should it be a structure? Should it be an array? Or should it be something more cute, more simple, more easy? Okay? What I would like is, I would like something like this. M X S A. standing for min, max, sum, average, equal to my function, body of the function. So here, the body of the function is returning, we call it a 4 tuple, or a tuple with 4 elements. This is far more elegant than returning an array, because in an array, somebody has to kind of pretend is ARR 0 the sum, or ARR 0 the min, ARR 1 the max, how do you know? Whereas here, it is pretty explicit. The way I have declared my variables ensures that I have a return type, which is a tuple of values. So my function is a multi-purpose function. It is not just giving me the min, the max, it's giving all of them. But it's giving me a nice cute tuple, which I can then use, convert it into a list, or use it in any different way. So this is not possible in a language like Java, C, C++, or for that matter, any of the conventional programming languages. It's not possible to do that, right? Python and basically these functional programming languages were the earlier ones to introduce this idea of a tuple. Do you understand a little bit about what is a tuple? We'll talk about tuples at length, but at this stage, yes, it's a cute idea. It's an easy idea, but you have to know when to use it. When you want a group of values which have to come out from a function in general, but they cannot be an array because they are different people. A min has nothing in common with a max and has nothing in common with a sum other than having the same data type perhaps, or not even that. The average may not have the same data type, right? Maybe a float. So grouping them into an array is kind of irritating, doesn't gel right. You should have them as different variables in your program, and that's what I just showed you. This is what is called a tuple, and tuple is used for these kind of things. Okay, we'll move on. So we have a list, we have a tuple, we have a set. The only thing which a set offers is it doesn't tolerate duplicates. So if you are, for some reason, want to get rid of duplicates, you can convert a list into a set and get rid of duplicates. Okay? Apart from that, honestly, if I have a choice of using an iterable, I would go for a list rather than a set. Only when I want to ensure somehow that all the elements in my list have to be perforce unique, then I would use a set. Otherwise, I wouldn't employ a set in my program. Okay? I don't have a very strong use case for using a set. I will prefer using a list. So set is a collection which is unordered. The other problem with the set is you can't ask a set, give me your first element. You can ask a list, first, second, third, because it's stored in a ordered manner. Set doesn't have any order. Set can only say, am I in the set or am I not in the set? Am I a member of the set or am I not a member of the set? Only that it can answer. It cannot answer anything else. The set can be converted into a list. Then it automatically enjoys all the properties of a list. We can begin a list. And then, it's unordered, unchangeable, and unindexed. Obviously, if it is unordered, it cannot be indexed. How can you say, when there is no ordering, can you say what is first, what is second? No. It's just an amalgam of elements. Then, of course, no duplicate members. That's the only significant advantage of a set, that it does not tolerate duplicates. Dictionary is obviously a very powerful data structure, as powerful as a list. So the ones which you need to master are the list and the dictionary. You get mastery over that, you're done. What is a dictionary? Dictionary is a key value mapping. Okay? And this is very common in programming. You need to store an employee number, and against that you want to store the entire employee object. Then you want to store a roll number of a student and store an entire student object against it. So you want to build a concept of a mental table, like a table where there is some key and against the key there is some value. So when you have that kind of an issue and that kind of a need of a data structure, obviously dictionary is the ultimate data structure. Dictionary is called dictionary in Python and it is called map in Java or C++. So when we talk about C++, you refer to the word as map. It's the same. I mean, the concept is the same. There is a map function, that is something else. Map data structure is exactly dictionary. A lot of languages use dictionary, a lot of languages use the word map. Moving on. So how do you access elements of a list? We already discussed that, that's trivial. First element is called 0 and so on, right? Up to len minus 1. So obviously they will be, if there are 8 elements, the indexing is from 0 to 7, just like in C. Then, the good thing now, this is where the list of Python's code over lists of or arrays of Java or C++ or C. You don't have this in any other language. The negative index. Suppose you have a bunch of sorted data in ascending sort and you want the biggest value. Okay. What do you have to do in C++ or C? You'll have to say length of that minus 1 in order to get that index. Oh, yes. Suppose I want the highest, we know it's sorted, but sorted in ascending order, and I want the biggest value. You are with me? If I want the biggest value, I have to go to the last element. What is the index of the last element? Length of that minus 1, right? So I have to use that as an index. It becomes pretty ugly to look at. This is pretty nice. Yes? I just say minus 1. Minus 1 means the last element. Minus 2 means second last element. And you can keep going back. Yes? Very elegant, very nice, and very easy to use. And only thing is you have to develop that intuition that minus 1 means I'm starting from the end of the list and coming backward. So, very useful. Next. Then you also have this very beautiful idea which you don't have in other languages, which is called slicing. I am interested in a part or a slice of a list. Let's say from the third element to the sixth element. So third element means 2, 5. 5 means the sixth element but not including the sixth element. Okay. So here, when you say, here it is, this list, square bracket. Okay. Remember, it's not parenthesis, it is indexing. It's kind of an indexing. So they want to suggest it's indexing. You can describe the slice. Slice has 2 parts. The starting index and the ending index. But the slice is from the starting index, not including the ending index, but ending index minus 1. So in this case, the elements which will be retrieved are the second means third element, which is cherry, orange. Yeah. So it will be cherry, orange, and kiwi. That is element number 2, element index 2, element index 3, element index 4. Element index 5 will not be retrieved because 5 is excluded. Just keep remembering that. Oh yes? 5 is not included. A lot of people forget this. I am emphasizing. So the last element is always excluded. The starting element is always included. Okay, when you describe a range. Okay. Going forward, we'll quickly move through this. Yeah. Go on, next. Now, here it gets even better. Now, how do you describe a slice? Start, colon, end. End is not included, ending minus 1 is included. But the flexibility is, if you skip the start index, then it starts from the beginning of the list and goes up to that point minus 1. Got it? No? Easy to understand. And same way, you can have the starting index but not have the ending index. Then what would happen? It would start from there and it would take the entire list till the end from that element. Correct? If you leave out the ending element. So, basic syntax is start index, colon, end index. You give both, it does accordingly. You skip one of them, it goes up to the ending index. If you skip the first, you skip the end, it goes to from that position till there. And if you skip both, what would then happen? It would take the entire list. Correct? No? That means you are not bothered about when to start, when to end. It means you start from the beginning and go up to the end. So it's like, if I want to show the entire list, I can just say colon, but then you can just say print list. Okay, so maybe we should just do this for a moment. Okay, so we have a list in which, this is a list with about 7 elements. So he's saying colon 4, so it will go from 0, 1, 2 and 3. So we have 0, 1, 2 and 3 up to orange. Now in that itself you change. Okay, you say 1 to 4. So it will take from 1, that is banana, and it will start from banana, cherry and orange. So it will just take that portion of the list. Yes? Clear, no? And then if I skip out that 4, it will start from banana and take the entire list. Yeah. Okay, so it takes the entire list from banana up to mango. Okay, so let's move on. This is interesting. Okay. Both the indices can be negative. Okay. So what does this mean? From -4, the starting index is -4 and the ending index is -1. So it starts from 4 elements from the last and does not include the last element, because the -1 is not included, remember? The same logic, ending index is not included. So -4, -3, -2. Yes? They are all there, but -1 is not there, because by the logic of slicing, the end of the slice is not included. Simple. Okay, so we start at, -1 will be mango, -2 will be melon, -3 will be kiwi, -4 will be orange. So it starts from orange, kiwi, melon and does not include the mango because the ending index is not included. Shall we move on? Now, what else can you do with a list? Okay. So here is an if statement. Now, I think, I'm hoping that most of you know that much of Python or have remembered that much of Python. How do you write an if statement in Python? So, if you want to write an if statement, you have to put a colon after the if statement. You can't put an open flower bracket like you do in C. You have to put a colon and give an indentation to do what has to be done if the if condition is true. And you can write an else if you want, or an else if you want, and write the code which has to execute. Again indented. So indentation serves the purpose of the bracket, and brackets without indentation don't make sense. Indentation makes sense. So here it is. So we have a list which contains apple, banana and cherry. So we are saying if apple in, so the syntax is, I can check for an element in a list, or I can say not in that list. So I can check for existence of an element in the list. So I am checking for existence. If apple in this list, then I say yes, apple is in this list. I think this is fairly easy. No, yes. Easy, no? What is that? Just if statement, colon, indentation. I'm just stressing that you should have indentation. Okay? Python is all about indentation. Okay, so moving on. Okay, you can change an item value because the list is mutable. So you can change the second element to blackcurrant because you don't like a banana, and that's it. Change a range of item values. Now this is interesting because this is not done very often, but verbs. Can we make it bigger, please? Control plus. Yeah. So you have a list at the top, and you are saying 1 to 3. Now 1 to 3, fortunately, consists of only 2 elements, 1 and 2, and you are replacing it with 2. But it need not be true. You can have a range of elements which may be 8 in range, but you can replace them with 3. Yeah. So it will cut out that slice, and in place of that slice, it will put these, whatever you want to replace it. What I am only trying to emphasize is, if you replace 8 elements, you don't have to give another 8 elements. You can give only 3. So the list in its complete size will shrink or expand. You are having a slice of 3 elements and replacing it with a slice of 8 elements. Perfectly fine. then the list will automatically extend or expand. No problem. There is no restriction. That is the beauty of mutability, of changeability. So here he is doing one-to-one, that we will get, in place of banana we will get blackcurrant, and in place of cherry we will get watermelon. Okay, so that is one way. Okay, next. And then you have, see here you have only one element which is getting replaced, which is apple, 1 to 2, which includes only one. And that is getting replaced with blackcurrant and watermelon. So the list starts with 3 elements, but ends up with 4 elements. That is, the list expands. Because that one element you are replacing it with 2. Clear? We move on. Okay, here we go. We are shrinking the list. You are replacing 1 and 2 with just one element. Perfectly fine. No restriction. Yes? We move on. Okay. Then you can insert an element at a particular point. So here you see we have 0, 1, 2. At 2 you are inserting watermelon. So where cherry is there, watermelon will commence it and cherry will move forward. Okay, automatically. So the element you are asking to insert is at that particular position. So you know what happened? Okay. But let's try this. Okay, instead of doing this, let's try. Suppose I had said 3. What would have happened? You getting what I'm saying? Now there is no 3. There is no 3, no? There is 0, 1, 2. But I'm saying insert at 3. Okay, let's see what happens. Yeah, so we got it at there. So let's say 5. So anything value given more, you're getting what I'm saying? If I give a value and say, I have only 3 elements and say insert at the 10th element something, it will obviously not insert at the 10th element. It will insert, it's like appending. Yeah? So you have to be careful about this. A lot of people think this would give an error. Now Python is not very, it's a very generous language. And sometimes I think that is not very good. Generous means very forgiving language. Okay? You gave me an index which is completely out of range. You know what? I'll be kind to you. And do what? I'll insert at the end. Because the value seems to be very big and I will insert at the end. Now, while that may be a good behavior to have when you are learning, but at times it's pretty irritating and creates trouble. This is again something which I would like to comment. I'll just make a few comments and I'll I'll continue. Especially I have seen people, when I teach them Python, they enjoy the language. Same kind of people, same group of people, same cohort of people. When we bring them to see, in Java especially, they start getting irritated. I said, Java? Java is a very nasty language. You know why it's nasty? It is very exacting. You have to say it the way you have to say it. Java doesn't give you much liberty. This is liberty. It says, what do you mean? There are 3 elements in the list and you are trying to insert something at 10th on bonkers. You know, that is the attitude Java will take. It will immediately throw up a big exception. Java erupts in it's like a very irritable person. You do something which is little different and Java just explodes. What the hell are you doing? Well, that's the attitude. I call it the language attitude. So, a conventional Java programmer is very orthodox, very conventional, very careful. When that same programmer comes to Python, this looks like a very liberal world. Anything goes, anything chalta hai. Java doesn't permit. Very intolerant, very orthodox. In Hyderabad we call it Aisach karna. Like it or leave it. This is how I am. Very difficult to make errors in Java. It just won't compile. It will say, I will not allow you to compile the program. Period. we have this list dot insert to watermelon allowed, even 5 allowed as we just saw. Next. Okay. Now how do you add? We already looked at this. How do you add elements to a list? You just append. Append. Go on append. Achha, you can append another complete iterable also to a list, which is called extend. It will just come. Meaning, if you want to concatenate two lists, make a list which is a bigger list, which is a sum of 2-3 lists, you can do that. You can just say extend. Append also you can do, but then you'll have to append one by one. You have to go loop and then do append and append, pretty irritating. Insert, just saw insert. Insert one orange, okay. Extend, this is what I was talking about. That is concatenating two lists. You already have one list and another list. So on the first list you say extend and give the second list. It can be a list, it can be a set, it can be a tuple, it can be a dictionary, it can be anything. All of that, of course, here we are showing a list. So you can add all the elements of that list at the end of the first list. So that is called extending. So if you want to make it big, don't use append. Append means you have to do one by one. And you just say extend and it will work. Okay. Add any iterable. So extend is with any iterable. Now you are seeing, I want you to grasp the nuance. This list is a list. The square bracket makes it a list. This tuple is a tuple. The braces. Yes, no? The braces make it a tuple. Tuple always has braces. And flower brackets is dictionary. So even if you just look at the kind of construct, square bracket, list. Parenthesis, tuple. Flower brackets, dictionary. Okay? So, yeah. Now extend this tuple. So it is another iterable. So it will extend it, and just like extending a list. Changeable also means you can get rid of elements. And this is where I was talking about in the morning. See, adding, inserting, all of this, they are giving you the visual of a list, but the behavior of an array or vice versa. So it's making it very easy. So you see here, you remove a particular item, you can just say remove banana and banana will go up and cherry will come in that position. Very simple. Okay, just say remove. Okay. You can remove like that, or you can remove, move forward. You can remove like that, or you can remove on the basis of an index. Now let's play with this a little bit. Try, run this. Here when you say pop 1, okay, this pop is in 2 ways, okay. Are you familiar with the stack? Anybody knows what is a stack? Okay. Stack was there, no? No? Yeah. Okay, let me just talk about a little bit on these two concepts. Have you heard of LIFO? Last in, first out. That is like called a queue. Do you understand what is a queue? No. Telangana queues are not common. Stand in a queue means what? Stand in all directions. That is not called a queue. That is called ganging up. Queue means, no, because this is class in Telangana, I have to tell. Queue means one person stands behind, before. The person who came later has to stand behind that person. Not create a separate queue and, So, in queue, we have to follow always a FIFO ordering. I think I said it wrong. So, queue is always first in, first out. The guy who came earliest gets served the earliest. Logical sense of things, right? So, a queue follows FIFO order. Everybody with me? Yes. But most of the, let's say, in many problems, the first in, first out is a good enough algorithm, which automatically queue implements. Because when you have a queue-like data structure, it will always say, if you ask give me an element, it will say, I'll give you the first one. After that, if you again say, give me the next element, it will give you the second element. Then it will give you the third. The way it was added, the same way it removes. First in, first out. For certain problems, you don't want FIFO, you want LIFO. That is, you want the last element to come out first. Whatever you added last. There are a lot of problems in which we will need a LIFO data structure. A list can serve as a FIFO if you write a loop, or it can serve as a stack. Stack is called, that means, sorry, I should say it this way. A list by default is a queue data structure, meaning it follows FIFO. But using this pop operation, it can be made to behave as a stack. Stack means what? LIFO operation. So a list is a double-edged sword. You use one end of the sword, you will get a queue. Use it differently, you will get it as a stack. Stack means last in, first out. You can use it both ways, depending on your nature of your problem. You can use it as a FIFO data structure, you can use it as a LIFO data structure. So we're going to see it's LIFO. So far, using FIFO is what? For I in list, print I. That is what, going one by one, from the beginning. Correct? But if I want to start from the end, of course you can always do -1, then -2 like that. But an easier way to do it is pop. Okay, now here we are seeing pop, where we are giving an index. Pop can be used two ways. Here when you say pop 1, it will give you banana. I mean, it will pop out banana. Or it will return banana. And you can print that. Now this will do, if you run this, this is giving you apple and cherry. But if I miss out that one, if I remove that one, if I just use this, it starts looking like a LIFO data structure. So what will it get rid of? Cherry. It will get rid of cherry. Are you with me? I say pop again. It will get rid of banana. Okay? So that is called LIFO. Last in, first out. Whoever came in last, last means here. Whoever came in last goes out. So the good thing is, so in languages like C++, you would have a stack and you would have a queue. Very common question in interviews is, why doesn't a list, why doesn't Python have a queue and a stack? Obvious answer is, we have a list, and list can be used either way. List, if you want to use it as a LIFO, use pop. If you want to use it as a FIFO, use it in regular iteration. Are you convinced about the answer? So you don't need something called stack, something called queue. In Java also you have queue and you have stack. Separate. Two different animals. Java, it's like a double-ended snake. You want LIFO, go to that head. You want FIFO, go to this head. It can work both ways. It's more useful. Okay. So we talked about popping. Here it is. This is like what I just mentioned. The use like stack, LIFO. So you simply say pop, you'll get elements from here. Okay. Yeah. So del. The del keyword is to delete a specific element. You can use remove also. But remove generally is index or element. In fact, you can use remove also. So, but here you are using it specifically as an element. So you say del. This list, the syntax is a bit different. Del removes it. But del, if you are doing this, you can as well use remove. No, yes. Okay. Del is more powerful when you want to delete the list. Now, deleting a list. Yeah. Can you go next? Next. This is okay. When you remove, there are two operations which you should be familiar. One is called deleting a list, other is called clearing a list. They are different. Deleting a list means the list itself disappears. Clearing a list means list is there, but it's empty. So if you want a list and just clear it out, means the list exists, but all its elements have removed. So that is called clearing a list. Deleting a list, everything gone. Are you with me? Yes? Pretty straightforward. Go down. Then, how do you loop through a list? How do you iterate through a list? Iterate means loop. How do you go from one element to the next? How do you retrieve all the elements of a list? Pretty trivial. For X in this list. Now, here, if you see Java or C++ or C++, you'll have to say first, what is X? You can't say for X in list. No. For int X in whatever, or the whole loop. Pretty cumbersome to write. This is so simple to write. I don't care. What do you mean? Why should I say for what? Whatever is in the list I want it. Where, int, float, all that. This too much of data typing is irritating. C++ needs it, Java needs it. Modern languages don't give a damn. JavaScript doesn't need it. JavaScript, I should say it. There are two JavaScripts, by the way. One JavaScript is the one which your uncles would use. Old JavaScript. Today's JavaScript is the one which is used for all this full stack development, all this great applications which you see getting designed. They are all with the new JavaScript. And that's way more powerful than what was there. In fact, we are already revising our syllabus for the next batch. We are introducing JavaScript early, the first year itself. So, we want that because JavaScript has become very important. Because it's both a front-end language and a back-end language. So realizing its importance, we are introducing it early. For you, we have it in the third year, but I think we have now made it more advanced. So for X in this list, print X. It looks very neat, and that's nothing very elaborate about it, or very difficult to understand. I'm just going through all the elements and printing it. Next. Okay. Looping through index numbers. So, if I want to write it that way, I can do it. Or here, I use I as an index. Then X was an element of the list. I is an index of the list. But if I want to use index, I should know from where to start and where to go. So I can say, for I in range, length of this list. Now, length of this list, range means what? It will start from 0 by default. You can also give range parameters. But here we have not. So if you are not given the starting parameter, it will start at 0 and go up to whatever the value which is mentioned. But obviously it will not include the last element. I mean, it will include not the length element, but length element minus 1 because you are going through the entire list. So the index, when you say length of this list, for example, for this, length of this list will be how much? 3. No? So the indexing will go from 0 to 2. The last element in the range is not included, just like in a slice. The last value is not included. So it is 0 to 2. 0, 1, 2. That means we are saying 0 to 3, but we will actually go to 0, 1, 2. Correct? So that is range. So that is using indexes. We'll use quite a bit of this. Okay. Using a while loop. So while, this is not very common, but it's there. While I less than length of list, do something with that element and say I is equal to I plus 1. This is like the old Tritayug way of accessing. But anyway, this is also there. Some people like it. It's a matter of taste. This is what most of our people use, especially people who are in third year and all. We prefer this style. This is called list comprehension. Where, if you see the conventional way, for X in list, print X, where the logic comes later inside the loop. That means what you have to do comes in the body of the loop. So first you create a loop and then say what do you want to do with each element in that loop. Correct? That is for X in list, that is the loop. And then you are saying print X. So the action you want to take is in the nested, and the loop is enclosing. You're getting me? No? Loop is the enclosure, and the action is nested inside the loop. Most languages prefer that style. First write the loop, then write what action you want to do inside that loop. Yeah? The other way of writing is called list comprehension, which is what? First write the action and then write the loop. Now you'll argue, do we really need both the systems? Well, as I said, it's a matter of taste. I have seen a lot of people prefer this. They first describe what should happen to each element and then say which elements it should happen to. It's like cart before a horse, horse before a cart. Okay, whichever way. Actually, that analogy is not happening. Okay, let's not get into analogy, but this is what we want. So first came the action, print x. That is what I want to do. For what I have to do? For x in this list. Honestly, do you like this style? I'm just curious. Or is that better? That is more conventional. I'm sorry? Single statement. You mean when the logic is, when what you want to do is less. Not really true. You can have brackets and write that stuff also. Meaning, you can do more than that. But yes, I agree with that when the logic is small and the looping is more intricate, then you would prefer this. When the looping is simple and the logic is complex, maybe you should prefer the older one. Again, your choice. I have seen people using either. Okay, next. Here is equivalent. This is now you will argue here the logic is a little more than what we have earlier. For x in fruits, if a in x, that means if the letter A is there in that fruit, then you should append that x to new list. Okay, you have started with a new list which is empty. That's how you create an empty list. Yeah, you understand this code? If I were going to write this code in our list comprehension style, how would I write it? What is the action you want to do? Wait. Go. What is the action you want to do? You want to append. So your action will be new list dot append x. Correct? That will be your action. Then your loop for x in list. But is it going to apply for everyone? No. So after that, you write the if. Always action is last. Action is first. And after that comes the loop. And in the body of the loop, you have a condition. So for x in this list, if A in list, this action should be done. Okay. Anyway, so how it will look in list comprehension style? This is x. I want x. Yes. For x. No, he's doing. This is okay. He's not. New list is equal to x. No, this you don't have to append. It is x for x in fruits. If A in x. Now that whole thing is in square bracket. So I have described the creation of new list entirely. What is creation of new list? This is another style. This is in derivative. The creation of new list is use x for it, but which x? For x in this list, which fulfills a condition. The condition being if A in x. Produce a list. Again, I am not going to say you should use this style. Next. So the syntax is, I want to prepare a new list. Expression, what I want to do. How do I want to prepare that new list? and then there is a condition for item in iterable. Iterable means some list. Fulfilling condition if condition is equal to true. If x not equal to apple, the other side of the story. I think this is easy. X for x in fruit is the same thing. X for x in range 10, another way of it. Okay, I think we are, expression can be anything. X dot upper. Yeah, I think this is okay. Yeah. Okay. I think we're pretty much done. So we've we have to still do sort. Okay, we'll need one more session perhaps. Yeah, I'll have to describe different kinds of sorting, mapping, filtering, reducing, all of that I'll cover next session. Okay, and then we'll talk about, I will give you some problems and we'll do them together. As I just go through this part, the remaining part, you know where to go. Yeah. Just finish this. And after you have finished this, just read what is map, reduce and filter. Can you do that? We'll discuss that next session, and I want to write some code.